Hi everyone, welcome again in a new video of Ignite. In the previous video, we have seen how we can use Ignite as an in-memory cache and how can we store the data in a disk for the Ignite persistence. But there could be a scenario wherein we have a data in external storage such as SQL database, NoSQL database, Hadoop or Elastic. And if we want to have a faster access to that data, then how Ignite can help there. So in this video, we will see how we can use Postgres database with Ignite to have the faster access of the data. To integrate with any of the RDBMS database, there are two ways. We can use the cache JDBC Pujo store when we have the database as a primary source of information. And if we are using the database only for the sake of persistence, then we can go with the cache JDBC blob store. So in this video, we will go through the cache JDBC Pujo store. To configure the cache JDBC Pujo store, we have to do a couple of things. First of all, we need to define one cache JDBC Pujo store factory. This factory will have the data source bean. This bean has information of database connectivity. And then we have the dialect. Ignite provides the implementation of different dialects compatible with different databases such as MySQL, Oracle, S2, SQL Server, or DB2. If we need to use any other database for which there is no direct implementation, then we can use the basic JDBC dialect. Like in our case, we have to use Postgres, so we will be using the basic JDBC dialect. And then we have the types. This provides the mapping between the database table and the Pojo class. Now let's look at the code. This part we already know from our previous video. We need to define one cache configuration for our new cache. In the database, here we have one employees table which has ID, name, and email fields. So we want to store this information in our cache. Ignite stores the data in the key value form. Key that we want to create is the ID of the employee, and then rest of the employee object as the value field. So here we have defined one cache configuration, integer as a key and employee as a value. We can define the name of this cache, set name, and let's give it a name, employee cache. Then this cache we have added into our configuration, and while starting the Ignite, we have passed this configuration. To define the database configuration, first of all, we need to define a Pojo store factory. So this is what we have instantiated. This factory requires dialect. Here we are using the basic JDBC dialect for the Postgres. If we have MySQL or any other database for which implementation is already there, then we can use that specific dialect. And then we need to set the data source factory. And here we have the data source factory. This has information of the database like driver, URL, username, and the password. For Postgres, because Ignite does not provide direct support, so we don't have any data source for that. For this particular thing, we have added additional library, which is Postgres dialect. So with the help of this library, we are able to access the driver manager data source. We have all the configuration for the connectivity related stuff. We need to define a mapping between the employee table and the employee class. Here we have the employee class, which has ID, name, and email, and in database we have ID, name, and email field. To define a JDBC type, first of all, we will define JDBC type, and with this type, we need to add couple of information. First thing is we need to define a cache name. This should be same as the name which we have defined in our configuration. So here it is employee cache. Let's give it a name, employee cache. Then we need to define a mapping between the database table and the employee. So here database table is the employees table. We have the key and the value type. Key type that we can set as the integer, and then we can set the value type, which is employee. We have defined the type of the key and the value, but we also need to tell which field is a key field and which fields are the value fields. So here in our case, ID is a key field. We can set the employees type dot set key field, and it is a JDBC type field. So let's instantiate that JDBC type field. Here this JDBC type fields takes couple of parameters like DB field type, DB field name, Java field type, and Java field name. This JDBC type field define a mapping between the database table columns and the POJO classes field. The first thing is the database type. For the ID field, we have the integer type. So the SQL type is the integer, and then the name of the field, which is ID. Similarly, we need to give the Java type. So here we have the integer type and then the name of the field, which is ID in the employee class. So this is the key field. Similarly, we need to set the value fields. Value fields can be multiple. Set value fields takes the where args. So as many attribute as we have in our table, we can set them all here. Like the first field is the ID, and let's add the other fields. So we have other field as name. DB field name is name, and then the Java is also name, and it has a type varchar. This is a string type. Similarly, we can add another field which is email, and that's it. And now this JDBC type we need to set with the factory. So here we have added this type. And finally, we have added this factory with our employee cache. This is the configuration we need to define to start our Ignite server. If we want to get the data from this cache, so here we have the Ignite cache. Let's open this. From this cache, let's get an iterator. So here we have the iterator of the cache attribute. If we have no value in our cache, then just print no value available. Otherwise, print the remaining values. So it will print all the values with key and then the value. Let's add one value here. And if we just close the server, run it again, so it still says no value available. This is because when we started this cache, it has defined the connectivity with the database, but it hasn't loaded any data from the database. To load the data from the database into our cache, we can just do that by applying load cache, and here we can just pass the null value. And let's rerun this application. All right, so we have got this value for key one is employee. This is our server application. And if we just need to make use of this cache in our client application, this is our client application wherein the client mode is true. And here we have the same cache that is what we have used in the server. And we have done the same thing. We are iterating through the values. And if we run our application client, let's see what happens. The same thing. We have one key. This is the value. Now, let's do one thing. In the database, let's add value 2. Let's restart the application. So here we have value for key 1 is employee, but it did not print the value 2. Why? Because when we started our Ignite server and we loaded the cache, it had only one value, which was the employee ID 1. And now we have added another value in the database, but this value is not available in our cache. How can we get that data? For that, in the server, with the data, we have to set the read through mode, which is set read through, and set the value to true. Whenever the client will try to access the data for specific keys, if those keys are available in our cache, the value will be returned from the cache. But if the value is not there in the cache, get the data from the database and store that within a cache and return the same. In the database, we will add one more value, 3. In the client application, let's print the value. And we want to get the value for employee ID 3. Let's run this. So it has printed value for key 1 is employee 1 and value for key 2 is employee 2. So this is what it has printed from this iterator. So that means in the cache, we just have two values. And now when we specifically ask for employee 3, it has read this value from the database. This was about reading the data from the cache and subsequently from the database. Now let's see one more example. Here we will add one more employee into our cache. Let's give it a key 4 and ID 4, employee 4, and let's run this application. So now here you can see that in the cache object, we have got value 1 2, 3, and the 4. This 4 value is what we have just added in our cache. And now let's look in the database. So here we have got only 1, 2, and 3 value. So the fourth value that we added into cache is not there in the database. And if we just stop our Ignite server, and in the client application, we have just commented out this put value. If we run the client application, so now it has just value 1, 2, and 3. It does not have the value 4 that we added into our cache earlier. That means this data is not persisted into the database. To persist the data in the database, we have a couple of approaches. First thing is the write through cache. In that way, whatever data we are updating into cache, it will immediately update it into the database. We have to add the additional configuration set write through and set it as true. Now, if we just restart the server and from the client code, let's add this value 4 and rerun this client code. So let's look at the database. Now here we have got the value 4. Whenever we are updating the cache, it will also update the database synchronously. But when we work with the cache, we'll look for the performance. And if we are doing two operations, updating the cache and updating the database, so the performance of our cache can be decreased. In order to have performance better, we can have another option. Here we will set the write behind mode. This is true. By setting this write behind enable mode, whenever our cache will be updated, it will not automatically be updated into a database. It will wait for some time. There are two options. The first thing is the time and another one is the size. If we set the flush size, say 2, in that case, it will wait for 2 entries to be added into a cache. And as soon as we have 2 entries, it will update the database. Also, there is one more property, which is set plus frequency 2 seconds. In our cache, if we will get 2 updates, like 2 entries, before 2 seconds, it will update the database. Or if we have only one entry within 2 seconds, so it will also update the database. So whatever is the least, it will update accordingly. By default, we have a couple of entries here, 10240. So this is 10K. And similarly, we have the default frequency. This is 5 seconds. So within 5 seconds, our data will be updated if we are not setting the value here. So right now in our cache, we have defined the write behind cache flush size as 2 and the frequency as 2 seconds. So let's make it 5 seconds. In the client application, let's add the value 5, and this is 5, and this is 5. In the database, let's see if we have the employees. So we have 4 employees right now. And if we run the client application, here, wait. And after 5 seconds, the value is updated into a database. Okay, even if we have only one value available here, but still because the frequency is 5 seconds, so it will update the database within the 5 seconds. Now let's increase the value of this to say 5 minutes. And from the database, let's remove everything. Now we have the write behind flush size as 2. And in the application, we have one value. If we run the application and look at the database, it does not have any value. Now let's do one thing. Instead of this 5, add one more value here, 1 and 1. Rerun the client application. So now after 2 entries, we have got this data in our database. When we set this write behind mode on, our performance will be better because now whatever update is happening in the database, it will be happening in asynchronous mode. While setting this write behind enabled mode, this write through mode has to be set. If this will be false, then there will be no update into our database. If we want to have a consistency, then the write through mode is what we needed. But if we want to have a performance, the write behind mode is required. In the next video, we will see how can we set the Spring configuration to make our code simpler. Till then, happy coding.